Hello everyone, and welcome back to our Roguelite tutorial series. In the last several videos, we've been deep diving into procedural generation, and we've been creating a dynamic dungeon that changes every time we play. We've laid out our foundation for generating rooms, hallways, and walls procedurally, building a unique dungeon layout every time. In this video, we're going to take it a step further and implement the dungeon traversal. We're going to allow the player to start at the entrance of the dungeon and traverse through to the exit. When the player reaches the exit, we'll dynamically generate a new level and teleport them to the start of the next dungeon. By the end of this video, you'll have a fully functioning system for your dungeon exploration and seamless progression between levels. Let's get started. So in this video, we're going to be creating a manager to load our new levels when we reach our level exit. So let's go ahead and create a dungeon manager to do that. So we'll right click, we'll create our new mono behavior script, and we'll call it dungeon manager. And then we'll go ahead and we'll open up this script, and then we're going to just remove everything out of here, since we're not going to need it all right this second. And then we're going to need to be able to access our dungeon from our dungeon manager. So let's create a new class to hold our dungeon information so it's all self-contained into one easy wrapper. So inside of our dungeon generation folder, we're going to right click and create a new file. I'm going to call this dungeon.cs. And inside of this script, we're going to go ahead and create our class. So this will be public class, and then we're just going to call it dungeon. Okay, and then we'll add our curly braces. And that's our dungeon class defined. So inside of here, we're going to need to add some settings for our dungeon. So let's go ahead and add in our width. We'll add in a height. We'll add in the number of rooms. So I'm just going to call this one num rooms as well. A minimum size, private int min room size, and a private int max room size. And these are coming directly from our dungeon generator. So if we go ahead and open that up and go up to the top, we can see that we have all of those same settings. And this is because these are the settings we use to create our dungeon. So we're going to need these inside of our dungeon script. Okay, so the next thing we're going to do is we're going to add our 2D array for our layout. So in our dungeon generator, we do that here in our generate dungeon. But in our dungeon, we're going to actually keep track of the actual grid layout. So we'll add in a private 2D character array. And I'm going to call mine dungeon layout. All right. Then we'll go ahead and we'll add in the characters we're going to use to differentiate from each position. So inside of our dungeon generator, we used a wall char and a floor char. So we're going to add those in here, but we're going to create them as constants because they don't ever need to change. So that'll just make things easier on us and make sure that other programmers, if you're working in a team, won't be able to break the rules of what these are. So they won't be able to change them at runtime. So we'll use a wall char, and that's going to be the same pound sign. And then we'll add a floor char, and that's going to still be our period. And then we're actually going to be determining a start and an end location in this video as well. So let's go ahead and just quickly add our characters for those. So we'll say start character, and that's going to be a capital S. And then we will have a end character, like an exit character. So we'll call it exit character. And that one's going to be a capital E. So we'll use these characters to indicate on our grid where our start location is and where the exit is. So then we're going to go ahead and create a constructor so we can create our dungeon, and we can set up all of these settings when we create it. So this will be kind of where we initialize our dungeon. So we'll pass in a width, we'll pass in a height, we'll pass in a number of rooms, and we'll pass in the minimum room size and as well as our maximum room size. Okay, so then we'll use the this keyword to set all of our settings. So we'll say this.width equals width, this.height equals height, this.num rooms equals the num rooms that we passed in, this dot min room size equals min room size. And this dot max room size equals max room size. Okay, so with our settings now initialized, we can go ahead and initialize our dungeon array as well. So let's go ahead and make every position in the layout a wall tile. So first we will go ahead and set up our new character array. So we'll say dungeon layout equals a new character array, and then we'll use the width and the height for our bounds. And then we'll go ahead and we'll loop through each of these. So we'll say int x equals 0, and then we'll loop through until x is at least as big as the width. And then we'll say x plus plus. And then we'll say for int y equals 0, and then we're going to loop through our y bounds. So we'll say height, and then we'll increase our y. Okay, and then once we've done that, we'll say dungeon layout xy equals our wall char. Okay, and this is doing the same exact thing that we did in our initialized dungeon here. So we're actually going to do that when we create our dungeon, so we won't need to call a function for that. So now that we've got the basics of our dungeon implemented, we'll need to update our dungeon generator to use our new dungeon class. So let's go ahead and go to our dungeon generator script, and we'll start in our generate dungeon function. So instead of this being a character char, we're just going to use our dungeon type, and that's going to cause some errors, so don't freak out. So right now we're setting our dungeon equal to initialized dungeon. So this is actually being done inside of our constructor, so it's not needed anymore. So we can go ahead and delete that. And we'll delete this reference to that function. And instead of calling initialized dungeon, we'll go ahead and create a new dungeon. So we'll say dungeon, and then we'll pass in our dungeon width, our dungeon height, our num rooms, our minimum room size, and our maximum room size. Okay, so that'll go ahead and create the dungeon for us. Let me close this. And then the next thing we'll need to do is update our generate rooms function. So let's scroll down to our generate rooms function. Instead of passing in a character array, let's go ahead and pass in our actual dungeon class. So that's going to remove that error here. But you'll see we actually have an error within our generate rooms function now. So let's look at what we're doing here. So in this section, if the room did not intersect, then we're going to add the room to our rooms list, and then we're adding the room to our dungeon. So let's go ahead and create a function to do that inside of our dungeon class. So let's go here outside of our constructor. We'll create a public. And this can be a void since we don't need to return anything. And then we'll say add room. We can pass in our room here. And then we'll have everything we need to loop through our room and then add our room to our dungeon layout. So in our dungeon generator script, we've got this for loop. So let's go ahead and cut that out of there, and we'll paste it inside of our add room function. And right away, we'll see that we've got some errors because we are using naming conventions here that do not exist inside of our dungeon. Let's go ahead and update this. So for every place we see room X, we're going to change it to room.x. So we'll do room.x. And then every place that we see room width, we'll say room.width instead. And then we'll do the same for room Y. So room.y, room.y, and then room.height. Okay, so that'll resolve those errors. Next, we're setting our dungeon XY position to our floor character. So let's go ahead and change this one from dungeon to dungeon layout. That will resolve that error. And then instead of floor char here, we're just going to use our constant variable now, which we've changed to floor underscore char. So we'll use that instead. And that's going to add the room to our dungeon layout. Okay, so then with that completed, we're going to go back to our dungeon generator. And here where we are adding a room, let's go ahead and call dungeon.addRoom, and then we'll pass in our new room. And that's going to add our new room to our dungeon layout. So that will work pretty much the same as it did before, except that we renamed things and it lives in our dungeon now. So then we'll scroll back up to our dungeon generator function, or generate dungeon function, and we'll see that this error is resolved. So we'll go on to our next one in connect rooms. So I'm going to command click this. If you're on Windows, you can control click it, and it's going to take us down to that function. And we can see that we're passing in a character array here, but we don't need to do that anymore. We're going to update it to our dungeon type. And that's going to cause some errors for our horizontal and vertical corridors because that is taking a character array, and we don't need to do that anymore. So let's scroll down to these, and we'll update our character array to a dungeon type as well. And that's going to cause some errors. So we'll add this as dungeon. Okay, so now we can't access our XY through our dungeon like this anymore. Instead, we'll need to update our dungeon layout inside our dungeon. And this is just adding a floor position to our dungeon. So let's go ahead and create a function for that within our dungeon. So what we'll do is we'll say public void add floor. And this should take in an X and a Y position. Okay, so now we need to check if the X and Y that we pass in here is within the bounds of our dungeon. Otherwise, it's going to throw an index out of range error. So let's go ahead and we'll create a public bool, and we'll say is in bounds. And this is going to take in an integer for the X and an integer for the Y. And then we can just check if our X is greater than or equal to 0 and the X is less than our dungeon width. So we can actually just say width, and our Y is greater than or equal to 0 and our Y is less than our height. So this is going to be the logic that we need to see if we're in bounds. Let's go ahead and just return the value of that. And then I like to put that in parentheses just so it's a little bit easier to read, and we can see that it's like separate, and I don't know, I like it, it's easier. And since we're only just returning one line in here, we can actually use this cool like equals and then our greater than sign to, instead of like saying return, we can copy or cut this out here. Cut, and we could paste it there. And then add our semicolon and then delete this. And that's basically the same thing. So all this is doing is it's doing like an anonymous function call here, and it's just returning this value. So I like to do that when we have those one-liners. I think it makes our code look a little neater. And I usually add these to the bottom of our function or the bottom of our class, so they're easy to find and they're not like weirdly peppered in between all the ones that have these curly braces and the ones that don't. Okay, so now that we've got that, we can use it to check if the XY position that we passed into our add floor function is within the bounds of the dungeon. If it is within bounds, then we can go ahead and add the floor. So we'll say dungeon layout XY equals floor char. Okay, so let's save that and we'll head back to our dungeon generator. And instead of using this, we'll use our new dungeon.addFloor function, and we'll pass in I and Y. We can go ahead and delete the line above it. I just added it below so I could make sure that I passed in the correct order. Okay, and then we'll do the same thing in our vertical. So we'll say dungeon.addFloor, and then this will be X, oops, not Y, I. And then we can go ahead and delete this line above it. Okay, so that's going to do the same exact thing as it did before. It's just setting our dungeon layout at this position to a floor tile. Perfect. So then if we scroll up, we'll see our connect rooms no longer has any errors. And then we'll scroll up further into our generate dungeon. We'll see our connect rooms thing here is good. The next issue that we see is with our paint floor tiles. So I'm going to just command click on this. If you're in Windows, you can control click on it and it'll do the same thing. It'll take you right to the function. So this opened up our dungeon visualizer script, and we can see that this takes in a character array instead of a dungeon object. So let's go ahead and change this over to a dungeon, and that's going to create some errors for us. So our first thing we see is this get length thing is no longer working, so That's because this is not a 2D character array anymore. So let's go ahead and grab the character array so we can loop through it. So we'll say char, make it a 2D array, we'll call it dungeon layout, and we'll equal that to our dungeon, but we need a way to get our layout from our dungeon because our dungeon layout is private. So let's create a new function called getLayout, and that will return the 2D character array. So let's go ahead and head over to our dungeon, and then after our add floor function, we'll add another function to return. So this is going to be a one-liner as well, so we'll just do it in the same fashion as the isInBounds. So right after the isInBounds, we'll say public, and then this is going to return a 2D character array. And then we'll say get layout. And we'll use our anonymous function to return our dungeon layout. Okay, so that'll give us our dungeon layout. So if we go back to our paint floor tiles, we'll see the dungeon layout here. Okay, so now that we've got our dungeon layout, we can go ahead and update our for loop here. So we'll say dungeon layout instead of our dungeon. We'll say dungeon layout there as well. And then right here, we're checking to see if this position in the dungeon is a floor tile. So let's add a function to our dungeon to check this for us instead of using this hard-coded value. So instead of our dungeon function, right after our add floor, we'll create a public boolean, and we'll call it isFloor. And we'll take in an x and a y. Then we'll need to check if the x and y position is in the bounds of our dungeon. And if it is within the bounds of our dungeon, we'll return if our dungeon layout xy equals floor char. So if the position in our dungeon is a period, then this will return true, and then if not, it's going to return false. And then if our xy is not within the dungeon, we'll just go ahead and return false by default. Okay, so now that we've got that, we can go ahead and we can update our logic here. So instead of saying dungeon xy, we'll go ahead and we'll say dungeon.isFloor, and we'll pass in the xy value. So that'll check if the dungeon position is a floor tile. If it is a floor tile, we'll get our tile position and then paint our tile. Perfect. So that's updated. And then we have another error down here at our generate walls function. And then again, command clicking here, we can see that this is also not a dungeon, the same dungeon type that we are passing in. So let's go ahead and change this character array to a dungeon like that. And then at the top, we'll do the same thing. We'll get our character array, call it dungeon layout, and we'll just say dungeon dot get layout. And then we'll switch our dungeons here to dungeon layout so we can get our height and our width from our dungeon layout. And then we're going to loop through the same way. And the next error we have is when we're checking if our neighbor position is a floor tile. So we actually added a function for this. So we can say .isFloor. And then we'll go ahead and change this bracket to a parenthesis. And we can get rid of this dot equals dot. Okay, so now if our dungeon is a floor, we'll add our binary tile type of 1. And if it's not, then we'll do a 0. And then further down, we have another error where we're checking to see if the dungeon layout XY is a wall tile. So instead of doing this, let's go ahead and also add a function for checking if it's a wall inside of our dungeon. So we'll say public bool is wall. And we'll say int x, int y. And then this is going to be the same logic here. So we'll copy and paste that from our floor. And then instead of checking if it's a floor char, we'll check if it's a wall char. So we'll go ahead and just change floor to wall. And that will conclude our logic for isWall. So then heading back to our wall generator, instead of using this here, we'll say not isFloor, isWall. And then we'll change the angle, these hard brackets into a parenthesis, and then we'll get rid of this check for the floor tile character. And that's going to resolve all the errors in our generate walls function. So that should get us to a good point where our dungeon class is now working with the logic that we already had instantiated and created. So let's go ahead and just double check that none of these files have errors. Okay, so this one looks good. Our visualizer looks good. Our wall generator looks good. Okay, so now what we'll do is we'll go to Unity and just make sure that our changes didn't break anything. So in Unity, we can just select our dungeon generator, make sure everything's still set and everything looks good. And we'll go ahead and click our Generate Dungeon button. And this should generate a new dungeon with no errors. So we'll do it again. So this is looking great. We've successfully transferred our logic for our dungeon into our dungeon class, and we're using it correctly. So next we'll see that we actually do have some warnings in here. They're not errors. They're not going to stop us from doing anything. But we'll see that we have some things in our dungeon generator defined that we're never using. Specifically our wall char and our floor char. So let's go ahead and just double click on this, and this will open up the script and it'll take you directly to where the thing is occurring. So we'll see that our wall char and our floor char now have 0 references each. And that's because we removed the code that's checking these in favor for our is wall and is floor code inside of our dungeon. So let's go ahead and just delete these since we're not using them. And we've already deleted our initialize dungeon function because we're not going to be using that anymore either. So let's just double check that everything still has a reference. So all of these look like they have references. Our generate dungeon has a reference. Our generate rooms has a reference. Connect rooms is referenced. And these two are both referenced. So that's all good there. So let's go ahead and save our script, and then we'll head back to Unity and we'll make sure that we don't get any more warnings. So we'll just generate dungeon and no more warnings. So everything is looking great now. So now that we have everything working here, we're going to go ahead and select a start and exit room so we can have a spawn location and an exit location for our player to be able to like traverse our dungeon and then continue generating more dungeons once they reach the exit. Okay, so let's go ahead and we'll open up our script. And at the very end of our generate dungeon function, we're going to go ahead and we're going to create a new private void, and this will be called select start and exit room. And we'll give it its curly braces. So this function is going to need our dungeon and the list of all our rooms. So we'll add those as parameters. So say list room, and this will be all the rooms in our dungeon. Okay, so then inside of the function, we're going to create a new random so we can use it to randomly select our starting room and our exit room. So system.random, random equals a new system.random. Okay, so then we'll choose our start room from our rooms list at random. So we'll say room, and we'll call it start room, and we'll just say rooms and then random.next, and we'll choose from 0 to our rooms.count. And then for our exit room, we're going to need to be a little bit more selective with our choosing. So we don't want to choose our start room or exit room the same way that we did our start room. We're going to want to be able to make sure that our exit room is not our start room and that our exit room is also not connected to our start room, because we don't want the player to be able to like spawn and then be able to literally leave the next room that they go to. So we're going to create another function and we're going to call it select exit room. So we'll say private, and we're going to return a room, and we're going to call this select exit room. And we're going to save that. And in order to select the exit room, we're going to need to pass in our dungeon, or not our dungeon. We're going to need to pass in our start room. And we're going to need a list of all of our rooms. Okay, so now that we've got that, we're going to need to be able to get a list of all of the connected rooms to the room that we're going to be checking. So in this function, we're going to loop through all of our rooms. If our start room is not the room that we're currently looking at, then we're going to see which rooms are connected to the room that we're currently looking at. If the start room was within that rooms list, those connected rooms, then we can't use that room because it means it's connected to our start room. So right now we don't have any way to see which rooms are connected to each other. So we're going to have to implement a new way to do that. So to do that, we're going to allow our room to keep track of which rooms are connected to it. So let's go ahead and open up our room, and we'll add a private rooms list in here. So we'll say room, list room, and then this is going to be our connected rooms. And then we're going to need a way to add a room to our connected rooms list. Let's go ahead and create a public function for that. So we'll say public void connect room, and we'll pass in the room that we want to connect. And then we'll just say if our connected rooms list does not contain the room that we're trying to connect, then we'll connect it. So we'll say connected rooms.add, and then we'll add the other room. Okay, so now that we have a way to add our add the room that we're trying to connect, let's also make sure we have a way to get our connected rooms list. So we'll say public list room, and this will be get connected rooms. And for this one, I'm going to use this method here since we're just going to return our connected rooms list. Okay, so let's save that. And now we will need a way to add rooms easily to make them connected. So in our dungeon generator, in our connect rooms function, where we're connecting our rooms together, we're going to, at the bottom here of inside of our for loop, we're going to connect these two rooms together. And I really want to make this like an easy to read, a succinct way to do this. So instead of saying like room I-1 dot connect room and then rooms I'm going to add a function to our dungeon that will help us easily connect some rooms together, where we can just say it in one line, pass both the rooms in, and be done with it. Okay, so I'm going to go over to my dungeon function, and at the bottom, underneath our isWall, we're going to say public void connect rooms, and then we'll say room 1, and room 2. And this is going to make this so much easier to read. So then what we'll do is we'll say room 1 dot connect room, and then we'll connect that room to room 2. And then we'll say room 2 dot connect room, and we'll connect that room to room 1. So now these rooms are connected to each other. So then inside of our dungeon generator, right after we add our corridor, we can go ahead and add the room connection. So now we'll say dungeon dot connect rooms, and now we can pass in rooms I-1 and rooms I. Okay, and that's a lot like cleaner than having like two calls with lots of these like brackets and numbers. So now we just have it one time. All right, so now that we have a way to connect our rooms, and all our rooms will get connected now, we can go ahead and figure out which rooms are connected to each other and make sure that we're not choosing an exit room that's connected to our start room. So inside of our function, let's go ahead and create a new system.random, so we can make sure that we're choosing a random room from our possible rooms. So go to a new system.random, and then we'll also create a list of rooms for our possible rooms. And we'll just create that to a new list. Then we're going to loop through each of the rooms that we're passing in our rooms list. So we'll say for each var room in rooms. And for each of these rooms, we're going to go ahead and we're going to check to make sure that our room does not equal our start room. Oops, that's not. Okay. So if our room does not equal our start room, then we're good. We can continue processing. So the first thing we'll do is we're going to get a list of all of the rooms that are connected to this current room. So we'll say list room connected rooms equals room dot get connected rooms. And then we're going to check to make sure that the connected rooms does not contain our start room. So we'll say if not connected rooms dot contains our start room. So if that list does not contain our start room, which means that this room is not connected to our start, we can go ahead and add this room to the list of possible rooms. Okay, so that's going to make sure that we're getting all of the rooms that are not connected to our start room, and those are the rooms that we can use for a possible exit room. Okay, so then what we'll do is we'll just choose a random room from this list. So after our for each loop, we'll say return, and then we'll say possible rooms, and then we'll say random.next, and we'll choose a random index between this and its count. Okay, so that leaves us at a good place, but if we only generate 1 or 2 rooms, then it's possible that our possible rooms list will be empty because all of the rooms will be connected to our start room. So we'll need to make sure that our possible rooms list has something in it before we can return. And if it doesn't have anything in it, then we're going to need to make adjustments. So we'll say if possible rooms dot count equals 0. So let's say we cannot choose a room that's not connected to our start room. Then we're going to go ahead and just set possible rooms equal to a new list. And we're going to just copy our rooms list. And we're going to choose a room at random from our rooms list. But before we do that, we're going to go ahead and remove our start room from the possible rooms to choose from. So that way we remove the start room and we'll choose any room at random that's not our start room. So this will allow us to choose a connected room if we have no other option. However, we still could possibly have 0 things in this list. So we'll go ahead and check again if our possible rooms.count equals 0. If it is 0, that means that we removed our start room from our possible rooms list and we were left with no rooms, which means the only room that was available was our start room, which means we only have 1 room in our whole dungeon. So if that's true, then we'll just go ahead and add our start room back to the possible rooms list. So we'll say possible rooms.add, and we'll add our start room. And this will allow our return function to randomly choose our start room. Since it's the only thing in there, it's going to choose it. So then we should be good here now. So we've covered if we've got a bunch of rooms, we've covered if we only have 1 or 2 rooms, and then finally if our dungeon only contains 1 room. So no matter what, our player will now be able to exit the dungeon. So let's go ahead and save that. And next we will go ahead and go back to our select, start, and exit rooms and then create a room, call it exit room. Then we're going to use our select exit room function to select our exit room. So then we'll pass in our rooms as our second parameter. Okay, so now that we have an exit room, we're going to need a way to set the location in our dungeon for our start and our exit. So to do this, we'll head over to our dungeon class and we'll add a function to do it for us. So underneath our connect rooms function, we'll say public void, and then we can say set starting location. We can pass in an X and a Y for that. And what we'll do is we'll check if our X and Y is in the bounds of our dungeon. And if it is within the bounds of our dungeon, we can say dungeon layout.x and Y position equals our start character. Okay, so at this point, I also want to save this XY position so we can use it to instantiate our player, because we're going to need to be able to get a position in the world for our player. So instead of like having to loop through our dungeon again later to figure out where the S is in the grid, let's just go ahead and save our actual position. So at the top of our class, just before our constant, right after our dungeon layout, we'll add a private vector3 int, and this will be our start location. And then we're also going to want to do the same thing for our exit location, so let's go ahead and do that just so it's out of the way. So we'll say exit location. And then I'm going to delete one of these spaces so it looks nicer. Okay, so then we'll scroll back down. And after we set our start location, we will set our actual start location. So we'll say start location equals, and then we'll create a new vector3 int. We'll use our x and our y, and then we'll leave the z blank, and that's going to automatically set it to a 0 for us. So that is our starting location. So let's go ahead and add a function to add our exit location as well, since we're going to need that. So we'll copy and paste this, and then instead of exit starting, we'll say exit. And then instead of our start char here, we'll say exit char. And instead of our start location, we will set our exit location. Okay, so that's going to give us that to use once we're ready to set our exit location. Then we'll head back to our generator, and we'll go ahead and we will say dungeon.set starting location, and we'll pass in our start room.center.x and our start room.center.y. And this is going to use our center of the room location for our player spawn. Okay, so we can see that we actually have some errors here, and that's because we actually don't have a x and a y to access through our center in our room. So let's go ahead and update our room. So we'll go ahead and enter our room, and then where we have our center, we can see that we're returning a pair of ints. So essentially what we're going to want to do here is just we're going to add an x to our first one and a y to our second, and that will allow us to use that .x.y. Okay, so let's save it. We'll head back to our dungeon generator, and we can see that those errors have been resolved. Okay, and then finally we'll want to set our exit room in our dungeon. However, we want to do some more processing because I do not want to set the exit to the middle of the exit room. Instead, what I want to do is set it along the wall so we can make sure that we can use like a door for our sprite, like to represent it on our actual dungeon in our scene. So what we'll do is we'll create another function, and I'm going to call it mark exit door. So at the bottom of our class, we'll create a private void. I'm going to call it mark exit door, and we'll pass our dungeon, and we're going to pass our exit rooms. This will be our room here. Okay, so then inside of this function, we're going to calculate all of the possible wall positions where we can place a door. So to do that, we'll create a list, and this is going to contain a pair. So let's just go ahead and name it int x and int y. And then this will be our wall positions. And we'll set that equal to a new list. All right, so then what we'll do is we're going to loop through all of the positions within our room, except instead of starting at 0, we're actually going to start at -1, so just one outside of the left wall. And then we're going to loop all the way through until we get to 1 outside of the right wall. So we're doing that because where our floor is where our room defines are. 1 outside of each boundary of that room is going to be a wall tile, since we're instantiating our walls around our room. So that's going to allow us to check our wall positions and see if the wall position is the correct type of wall in order to place a door along it. So first, let's go ahead and we're going to loop through each of our directions in our room. So we'll say int x, and this is going to be equal to room.x. And again, we're going to go 1 outside of the room so we can get our wall. So we'll say -1. Then we're going to say x is greater than or equal to our room.x plus our room width. So this means that we will go until we hit the room width. And when we're equal to the room width, we're 1 outside of the floor of our room. So that's going to be our right wall. And then we'll go ahead and increase our x. Then we're going to go do the same thing for our y bounds. So we'll say, oops, I just pressed y. Int y equals our room.y, and we'll subtract 1 so we get our bottom wall. Then we will go ahead and loop until we are room.y plus our room height. And that's going to make sure that we include our top wall, and then we'll increase the y. Okay, so now that we have that, we're going to check if our current location is a wall position. So let's go ahead and use our dungeon.isWall function. So we'll say if dungeon.isWall, and we'll pass in our x and y. And what that's going to do, oops, I used square brackets. So what that's going to do is this is going to check if the x and y is within our bounds. So that's kind of a double whammy check for us. And then it's also going to check if it's a wall character. So this is going to make sure that we're within the dungeon bounds and that it is a wall character. Okay, so then we need to make sure that we only place an exit door on a wall that is a center wall on our exterior walls. So that'll be like the top middle of our top walls. If it's a right wall, it'll be one of the centers. Essentially, it's going to ensure that we never place our door on a corner. And I think that's important. So let's go ahead and use similar logic to how we place a center wall in our wall generator. So what we'll do is we'll create a private Boolean function, and we're going to say is center wall. And we're going to go ahead and pass in our dungeon, and then also our x and y position that we're checking at. Okay, and then we're going to create a binary string for this one. So we're going to create a bit mask, and then we're going to compare against the bit mask for the walls that are correct within our wall types helper. So let's go ahead and create our string, and we'll just call this binary tile type, and we'll set that equal to a empty string. And then we're going to loop through all of the directions in our that are our neighbors. So this, we'll say direction, and we can access the directions list within our wall generator through our dungeon visualizer. So we'll say dungeon visualizer dot wall generator and then dot directions. However, this is a private list, so let's go ahead and head over to our wall generator and just make it public so we can access it. Okay, so then I'm going to close my wall generator script and close my dungeon visualizer so we don't have too many things open. And then you can see that we can access that now. Okay, so with that change, let's go ahead and figure out where our neighbors are. So we're going to get an int for our neighbor x, and we're going to set that equal to the x that we passed in plus the x direction for our current direction. And then we're going to do our y. So neighbor y equals y plus our direction dot y. And that's going to give us an xy coordinate in our grid for our neighbor. Then we need to check if our neighbor is within the bounds of the dungeon. So we'll say if dungeon.is in bounds, and then we'll pass in our neighbor x and our neighbor y. Right? And so if our dungeon if our neighbor is within the bounds of the dungeon, we're going to check to see if the neighbor is a floor tile. So we'll say if dungeon.is floor, and we'll pass in our neighbor x and our neighbor y. And if our tile is a floor tile, we'll go ahead and add our binary tile type plus equals 1. Oops. There we go. Okay. So then if this is not a floor tile, so else, we'll go ahead and set our binary tile type. We'll add a 0 to it. All right. So then what we'll do is after our loop, we'll go ahead and convert our binary tile type into an integer. So we'll just call it tile type, and we'll use our convert dot to int32. We'll pass in the string, and then we'll say we want to convert it to base 2, which will give us a binary number. And then we can return a value that lets us know if this is a center wall or not. So we'll say return. And then I'm going to add these parentheses so we can add our logic in between. So the logic that will let us know if this is a center wall is going to be our wall types helper. And then the wall that's a center wall for my walls. So let's go to Unity real quick. So the walls that I'm using, so all of these ones, the top here, that's going to be called top wall tile for me. Okay, so top wall. And then all of these ones that are not a corner for left, it's going to be called left wall. For my right, they're called right wall. And then for the bottom, they're called bottom wall. So those are going to be the ones that I'm going to use. So we'll say top wall dot contains, and then we'll pass in our tile type. So if the top wall contains this one, or our right wall, oops, that's not the right thing. This is generator types helper dot right wall dot contains our tile type. Okay, or our wall types helper dot bottom wall dot contains our tile type. And then lastly, we'll check our left wall. Oops. Dot left wall dot contains our tile type. Okay, so this will return true if our top wall contains it. So then if our top wall doesn't, if our right wall does, and then it's just going to allow this to check if any one of these things returns true. We'll go ahead and return true. If all of them return false, this will return false. Okay, so now what we'll need to do is we'll need to use this function to check if it's a center wall. So we'll say if our dungeon is a wall and our position is a center wall, and then we'll pass in our dungeon, the current X and the current Y. And then we can go ahead and head into our if statement here. If this dungeon position is a wall and it is also a center wall, then we're going to go ahead and add the position to the possible position to choose from. So we'll create a pair and we'll say XY. Okay, so then after our for loops here, we can check if our wall positions count is greater than 0. Okay, so if our wall positions count is greater than 0, it means that we added some positions to be able to put a door on it for our exit position. So what we'll do is we'll select a random. So we'll use system.random, call this random. It's the equal to a new system.random. And we're going to select a random wall position from our possible walls list. So we'll say var, and then I'm going to call this XY. And we're going to do wall positions, square bracket, and then we'll say random.next. We'll choose between our 0 and our wall positions.count. Okay, so that's going to select a random wall position for us in all of the valid possible wall positions. And then we can go ahead and call our dungeon.setExitLocation, and we will use our X and Y from the random position that we chose. So that's going to choose a random wall location in a valid spot. All right, so let's go ahead and call the mark exit door function from our select start and exit room. So we'll do that right after we set our starting location. So we'll say mark exit door, and we'll pass in our dungeon, and then we'll pass in our exit room. Okay, so then we need to make sure that we call the select start and exit rooms function from our generate dungeon function. So let's just go ahead and do that after we connect our rooms together. So we'll say select start and exit rooms, and we'll pass in our dungeon and our rooms list. Okay, so now that we had added our select start and exit rooms, we'll need to add a little bit of logic to make sure that we can actually display our start and exit rooms on our tile map. So what we'll do is we'll open our dungeon visualizer first, and in our paint floor tiles, where we're checking to see if our current tile is a floor tile and then we're painting the floor tile on, we'll also need to check if we have a start position. Because right now, if we were to generate this, we would have a blank tile for a start position. So what we'll do is we'll go ahead and go to our dungeon, and we'll add a way to check if it's a start location. So right after isWall, we'll add another public bool. We'll call this isStart. We'll pass in an X and a Y value. And And then we'll go ahead and just copy and paste our contents from is wall into our is start. And we'll change wall char to start char. And then let's do the same thing for an exit. So we'll just copy and paste that. And we'll say instead of is start, we'll say is exit. And we'll change this from start char to exit char. And we'll save that. So now we have a way to check if we have a start position and if we have an exit position. Okay, so let's go ahead and go to our dungeon visualizer, and then just right after we check if is floor, let's check else if dungeon.isStart. And if this is a starting position, we'll need to, instead of using our floor tile, we'll need to use our start location tile. So let's go ahead and we will head up to our floor tiles and we'll add a new tile. And then I'm just going to call this start tile. Okay, so then what we'll do is we'll scroll back down and we'll call paint floor tiles. And the first thing, sorry, not paint floor tiles, paint to tile. And the first thing that we need is a position. So we actually have a position already working for us here inside of our is floor. So let's go ahead and just move that outside of the if statement since we're going to need it for both the if and the else if. Okay, and then we'll use that tile position. And then we'll say our floor tile map. And instead of our floor tile, we'll say our start tile. And that will make sure that our start tile is painted onto the tile map. Okay, so next we're going to go ahead and do our wall generator to make sure that our exit door gets painted onto our tile map. So we'll go to our wall generator. Inside of our generate walls function, we'll see where we're checking if our dungeon is a wall, if that position is a wall, and then we're painting that wall tile on. So this one's going to be similar. We're going to need to move out our position outside of this if statement. Let's do that, and then we'll clean up the spacing here. And we can see that our paint wall tile is actually taking in a vector 2, and this is a vector 3. So let's go change this to vector 2 so we don't have to cast it. It doesn't really make sense to cast it when we're defining it like right before we're using it. So let's go ahead and delete that. Okay, and then after we check if is wall, we'll say else if, and then we'll say dungeon.isExit at our x and y. And if this is the exit position, we're going to have to get which exit tile to use, since we can have a possible of 4 directions. So before we continue, let's go ahead and save, and then we're going to create a new helper class. So just like we had our wall tile types helper, we're going to have our exit types helper. So let's go ahead and in our dungeon generator script, oops, I did not mean to create a folder. I meant to create a file. Right, new file. We'll call it exit types helper, and then .cs. Okay, and then in here we'll create our class. We'll say public static class, and this will be exit types helper. All right, and then we'll save that. And then inside of our wall types helper, we're going to find that top wall, left wall, bottom wall, and right wall. We're going to go ahead and just copy and paste these into our exit helper because we're going to need these exact positions. So we've got some issues. So let's go ahead and just do command period on one of these hash sets and then choose using some system collections.generic. That's going to add our using tag for us and make sure that all these errors go away. All right, and then I'm going to go ahead and just rename all of these to be more specific to exits. So we'll say left exit, bottom exit, and right exit. So that way when we're looking at the code, it's not confusing, and we can for sure know that this is going to be an exit and not just a wall. Okay, so let's go ahead and close that, and then we'll close our tile helper. And then what we'll do is back in our wall generator, we'll get a new tile. But we can't use our get wall tile because our exits are going to match our top, left, right, and bottom walls. So we'll need to create a new function that's going to handle our exits. So let's go down to our get wall. And just right above it, we'll say private tile base, and then we'll say get exit tile, and then we're going to pass in our binary tile type string. Oops. Okay, so then we're going to need to convert this binary string into an actual binary number. So let's go ahead and grab our tile type from our get wall tile, and we will paste it in there. And then before we check what type we're having, let's add a return statement for our default. So if we can't find any of the types, we'll just return null. We don't really have a default exit tile that we want to use at the moment, so we'll just say null. And then in between these two lines, we'll go ahead and add our if. And then instead of wall types helper, it'll be exit types helper dot top exit dot contains our tile type. Then we'll go ahead and return our top exit tile. And our top exit tile doesn't exist yet, but we're going to add it in a few minutes once we get all of these added. So I'm going to add 3 more of these in. And then before each of our else ifs down here, we'll say else. And then we're going to change each of these. So this one will be right. Then we'll change this one to right. Our bottom. I'll change the return one to bottom. And then this last one will be left. And this one will be left. Okay, so let's go ahead and generate all of these. So we'll just command period and then generate field. This is going to generate them as private fields at the bottom of our fields list. That's not where we're going to want them, so we're going to have to go up and move them. All right, so let's save. We'll scroll up to our fields list, and then here's all of our private fields we just added. So let's cut those and we'll paste them. I'm going to do it above all of our tiles here, so I'm just going to create a new header. And I'm going to call this exit tiles, and then I'm going to paste them there. And then we're going to change private to public so we can set them in the inspector to the tiles that we want to use. Okay, so let's go ahead and save that. And make sure that we don't have any issues with our function. So this looks correct, and then we're calling the function. So we're not calling it here, we've just copy and pasted our get wall. So let's go ahead and change that one to get exit tile. And then we'll use our dungeon visualizer to go ahead and paint the wall tile. And so we'll say tile position, and then we'll use the tile we just got, which is our exit tile. Okay, so it's going to go ahead and paint our exit tile onto our tile map. Okay, so I think we're at a point where we can go ahead and test this out and make sure that it is working. So let's go back to Unity. And then on our dungeon visualizer, we're going to have our start tile now defined here. So let's go ahead and choose a tile for that. So in our project structure, I'm going to go to my tiles folder, choose a ground tile for our start tile. And I'm going to use this like little grid here. So I'm pretty sure this is like a sewer drain. So I'm just going to use that. And then for our exit tiles in our wall generator, I'm going to go to my wall tiles folder. And I've got these like doorways that don't have any doors, so I'm going to use those. So this is my top, and this is my right, and this is my left. And then we'll use our bottom here. Okay, perfect. So that'll give us our exit tiles. So now let's go ahead and save our scene, and then let's try generating a dungeon. Okay, so it actually looks like we have a console error, so let's go ahead and check there. So it says if not connected rooms contains other than connected room. Okay, so I think what we did is we just didn't initialize our connected rooms list. So we'll need to do that. So we'll say new list of connected rooms. So if we don't add this new list, it's going to be equal to null. And we can't actually access anything within here if it's a null, which is why we were getting that error. Okay, so let's just make sure that this gets initialized to a new empty list. We'll save, and then when we go back to Unity, all right, so when we generate a dungeon, we should see that we have an exit tile and we have a starting tile. So it worked. We can see that our starting tile was added to the tile map at the center of our starting room, and our exit was added to a center tile along one of our walls. Okay, great work, guys. So the next thing that we're going to do is we're going to add the logic to be able to enter our exit location as our player, and then spawn a new dungeon and teleport the player to the new starting point. So this is where our dungeon manager is going to come into play. So let's go ahead and open up our dungeon manager. So we'll go back to Visual Studio Code. I'm going to close out my room, close out my wall, just really close out everything here except for our dungeon manager. Okay, so our dungeon manager is going to need access to our dungeon generator so we can create a new dungeon. So let's go ahead and add the field to the top of our class. So we'll say public dungeon generator, and I'm just going to call it dungeon generator. And we're also going to need our level exit prefab to spawn into the world at our level exit. So let's go ahead and create a public level exit. We'll call it level exit, and then I'm going to call it prefab. Prefab, not feb. Okay, so then we're also going to need to be able to keep track of the dungeon that we generated so we can get our player start and exit locations. So we're going to create a private dungeon, and I'm going to call it current dungeon. Okay, so then we'll add a start function to our class so we can generate the dungeon when the game first starts. We'll say private void, and then we'll use start. Okay, so this will get called as soon as the game starts, and inside of our start function is where we're going to kick everything off. So now that we've got the basics added to our dungeon manager, let's go create a generate dungeon function that's going to return the dungeon that got created. And this is going to allow us to set our current dungeon equal to whatever dungeon we created after we created it. So I'm going to open up the dungeon generator script, and inside of our dungeon generator script, I'm going to create a new public function just underneath our generate dungeon function, and this is going to return our dungeon, and I'm going to call it create dungeon. Okay, and essentially what I'm going to do is just copy and paste this from our generate dungeon into our create dungeon function, and then at the end we'll just return our dungeon. Okay, so that is our create dungeon function. So now that we've got that, we can go ahead and return to our dungeon manager script. And inside of our start function, we'll set our current dungeon equal to dungeon generator dot create dungeon. So that's going to generate our dungeon, select our start and exit, and set everything up in the dungeon class that we created. Okay, so then our dungeon can be created in this scene. We'll now need to move our player to the starting location of the dungeon. So let's go ahead and grab a reference to our player. So we'll just say public transform. No, that's not correct. Transform. And then I'm just going to call it player. And then inside of our start function is where we're going to set our player's position. So before we can do that, though, when we return our start position from our dungeons, let's go ahead and take a look at that. We're giving it a vector 3 int, which is fine. But when we're setting the location, we're just setting it to be our X and Y on the grid. And so what that means is that on the tile map, that X and Y position is at the bottom corner of the tile. So when we get this location, it's actually going to be at the location of the bottom corner of our tile. So what we'll need to do is create an offset in order to move the player to the center of the tile. So let's create a private, and this will be a vector 3. Vector 3. And I'm going to call it spawn offset because we're going to need to do the same thing with our exit location as well. So spawn offset, and then we're going to set that equal to a new vector 3, and we're going to add half to our X and half to our Y. And the reason that we're adding half is because our tiles in our tile map are 1 big. So if we go to our grid, we can see that our cell size is set to 1. So that means each one of our cells is going to take up 1 unity unit in each direction. And you can actually change this to be whatever you want. So if I did 2, all of these tiles, so you can see that all of these no longer fit in there and our tiles are bigger. And that's because these tiles are set to take up 1 space, and our tiles are now 2 spaces big. So if we set this back to 1, we'll go ahead and see that all of those fit seamlessly together. Okay, so the reason that we're doing half is because we want to move to the center of one of these tiles. So we'll zoom in here. So if this corner here is our start position, so this is the position that our tile is at, in order to move into the center of the tile, we need to add 0.5 to our x and to our y. And that's going to be true no matter where each one of these is spawned. We're always going to move 1 to our right, 1 up, and that will get us to our center. Okay, so let's go back to our dungeon manager, and we've created our spawn offset. So let's go ahead and position our player in our start function. So we'll say player.position, and we'll set this equal to our current dungeon dot get. Oh yes, we're going to need a way to get our start location. So we actually don't have one yet. So we'll save this. We'll open up our dungeon and we'll quickly add a way to get our start location. So down at the bottom, we're going to just under our get layout, create a public vector3 int. And we're going to call this get start location. And we will return our start location. We'll copy this, paste it right below, and then we'll change start to exit. And we'll change start to exit for our returned value. Okay, so that's going to make sure that we can get our start and exit locations from our dungeon. So now you can go here and say get start location, and then we're going to add our spawn offset. All right, so that will get us moving our player into the correct position. So now what we're going to need to do is we're going to need to instantiate our level exit prefab at our position in our world where our exit is. So to do that, we're going to go ahead and instantiate. So we'll use the instantiate function. We're going to pass in our level exit prefab because that's what we're going to instantiate. Then we're going to get our current dungeon dot get exit location plus our spawn offset as our position, and then we'll say quaternion dot identity for our rotation. And this is actually quite long, so let me go ahead and just get this so it looks a little bit easier to read, so you don't have to read all the way across. All right, so that's our instantiate. So let's go ahead and save our script, and we can actually test out our changes at this point. So oops. Great. Control S or Command S if you're on Mac. And then we'll go to Unity. I'm going to zoom out so I can make sure I can see my whole dungeon, and then we can clear these. And our dungeon, generate dungeon button. Oh, we forgot to set up the manager. So actually, before we do that, we'll go ahead and in our hierarchy, we'll create an empty object. We'll call this dungeon manager. And then on our dungeon manager, we're going to set our X, Y, and our Z back to 0. And then we will add our dungeon manager script to it. And now we're going to set this up so we can then move our player and add our level exit prefab. So we'll drag our dungeon generator from the scene into our dungeon generator field. And then we need to create our level exit prefab. So in our assets folder, let's create a new folder. Call this prefabs. And then we're going to just drag our level exit from our scene into the prefab. So in my scene, I've actually turned all of these off for testing so I can easily see the dungeon without any of these things getting in my way. So I got to turn them all back on. And then I will select my level exit and then drag it into my prefabs folder. So it's going to create the prefab for me. Now that I have a prefab, I can go ahead and delete it from the scene. And then we also don't need the spawn point anymore, so we'll delete that as well. Okay, we'll save. We'll click on our dungeon manager, and then we'll drag our level exit to our level exit prefab. And then lastly, we need our player. So let's go ahead and drag our player from our scene into our dungeon manager. All right, let's save those changes. And now what we'll do is we'll go to our dungeon generator. We'll click generate dungeon. And we should see this working, but it's not. Oh, because we're not playing. Okay. The reason this isn't working is because we're not playing the scene. Okay, because this is on start, remember. Okay, so let's go ahead and hit play. And then this will work. Okay, so we see that our player is on our start position and that our exit position is on our exit. So let's verify and make sure this is true. So I'm actually going to just move the player, and we can see that there's our start location, so that's good. And then we'll move our level exit, and we'll see that that is where our level exit was added. Okay, so this is working perfectly. So let's go ahead and quit playing. And I'm actually going to just resize my player so it's a better size for our dungeon. So we'll go ahead and change this from 0.1 down to 0.4 so I can make sure we make it through those hallways. Okay, we'll save those changes. And then I'm also going to turn off my level exit so it doesn't look like a red box in the scene. So what we'll do is we'll just turn off the sprite renderer so when it's instantiated, it will not be visible. So if we go ahead and choose our to play, we can see our player here now, and then the red box is not on our level exit. Okay, so now our player can move around in our dungeon. However, we can go over the walls, and when we try to leave, we can't actually leave because we haven't set up that. And also, if our player moves off screen, they're off screen. So we're going to go ahead and create a camera follow script to make sure that our camera can follow our player around. All right, so let's stop playing, and then make one last adjustment here as my player was super tiny on the screen. So I'm going to go ahead and just change my orthographic size on my camera. I'm going to set it to 4, I think. I think that will be a good size. So let's go ahead. We'll just play this. And I can't see the player on the screen. So let's go ahead and move our game to like one side, and then I'll click in there, and then we'll just move the player until they're in the camera. Okay, cool. So they're in there, and I think that that is a good size for a player. Okay, so I think 4 is going to work out for us. All right, well, so we'll stop playing, and okay, so then I'm going to put my game tab back, and let's go ahead and create that camera follow so that way our camera can easily follow our player. So we'll get that out of the way. So in our assets folder, we'll go to our scripts folder, and then in here we'll create a new C# script. I'm going to call it camera follow. And this is going to be a very simple script for us to just easily test out and be able to see our dungeon as our player is traversing it. So we're going to need our start and update function. So let's go ahead and just delete the comments. We don't really need them. And then inside of our camera follow script, we're going to need a target in which we're following. So we're going to create a public transform reference, and we're going to call this target. And this is the target that we're going to be following. And then we also need to, we're going to create an offset variable. This will be private, and it's going to be a vector 3. And this is going to calculate the distance from the target and then make sure that that is maintained. So whenever we create our target, and then we'll make sure that our camera is where we would like it in terms of our offset to our target. And then when we play, it's going to maintain that offset. So let's go ahead and call this offset. And in the start function, we'll set our offset up. So our offset is going to be the transform.position of the camera minus the position of our target. And then on update, we're just going to move our camera to the new position that needs to be in. So we'll say transform.position, and we're going to set this equal to our target position plus our offset. Okay, so that's going to add our motion to our camera. This is just some super simple logic, and we'll likely come back and change our camera follow so we can have some more cool features with our camera, such as like smoothing and having like a little area within the center of our camera so we can move. And then once we move outside of that center, then we'll move the camera. So let's go ahead and head back to Unity, and we'll slap our camera file script onto our camera. So we'll do that, and then we'll drag our player in as our target. So next we need to set up our player and our camera to be in the same position. So we can say our player's at 0, 0, 0, and then our main camera needs to be at 0, 0 as well. And then we're going to maintain this -10, because if we change this, we will no longer be able to see our player because it's occupying the same space. So this needs to sit above our player so we can see down onto it. So the default value is -10. It doesn't need to necessarily be -10. It can be -1 if you'd like it to be, but I'm going to use the default position of -10. And that's going to make sure that we can always see our player, and we can even add some layering down here if we need to physically move something up. But for now, this will be good. Okay, so our camera is at 0, 0, -10. Our player is at 0, 0, 0. So that's the offset that I want for my player. So now when we click play, we can see that our camera will move and follow our player. Okay, so we can never lose our player now. We'll always be following it and making sure that we've got our player in the center of our camera. Okay, so that was going to help us with testing a lot. So then let's go ahead and add our functionality to our level exit. So let's go ahead and open up our level exit script. And we've got a lot of stuff in here. So because our dungeon manager is going to be handling instantiating our new level, we're also going to give responsibility for cleaning up to our dungeon manager as well. So that means we won't need our clean up previous level logic. And we're actually not going to need our teleport anymore because we're going to just do that up here. It seems silly to have a single line within our teleport player function. So we'll delete that one as well. And then we can delete the references to that inside this if statement. And then finally, we're actually not going to need any of these anymore either. So this class has become super simplified. Okay, so now once our player enters our trigger, what we'll do is we'll call the dungeon manager and we'll tell it, hey, we need to generate the next level. So let's go to our dungeon manager script and we'll create a function to handle that. So we'll say public, and we'll say we're going to return our player's starting position, so where we need to move our player. And we're going to let our level exit move the player for us since we already have a reference to our player through our level exit. So let's return a vector 3. And this is going to be called next level, just for simplicity. Okay, so what we'll do is we're going to use all of the logic from our start function. So let's go ahead and just cut that from our start function and paste it into our next level function. Right, and instead of setting our player position directly here, we can just return this value now. So let's go ahead and cut this, and then at the bottom we'll create a return function, and we'll paste that back in. And then we can get rid of this player position equals because we don't need that anymore. Okay, so the next thing for us to do is give our level exit a reference to our dungeon manager so we can call that function. So let's go ahead, and in here we'll create a public dungeon manager and we'll call it dungeon manager. And this will not be set in the inspector. It's going to be set by our dungeon manager when we spawn in our new level exit. So let's go ahead and head back to our dungeon manager. And in order to set it, we're going to need a reference to our level exit that we created. So let's go ahead and in front of instantiate, we'll say level exit. I'm just going to call it exit and set that equal to the instantiate call. And then after our level exit, we can say exit.dungeon manager equals this. Okay, so the logic that we had, oops, not in our dungeon. Let me just close the dungeon. We don't need that. Okay, so in our level exit, the previous logic that we had was when we clean up our level, we're just going to delete the level parent from the world, and that's going to clean up everything underneath it. All of its children will be gone. So we're going to use the same structure, but instead of doing it in our level exit, we're going to do it in our dungeon manager. So first things first, we need to create our level parent every time we generate a new dungeon, because the previous dungeon will have deleted that parent during cleanup. So what we'll do is we will, above our current dungeon in our next level, is create that new game object. And we're going to need a reference to it because we need to hold on to it until it's time to clean up our dungeon. So after our spawn offset, let's go ahead and create a private transform, and we'll call this level parent. Okay, and then what we'll do is we'll set our level parent equal to a new game object. Okay, so level parent equals new game object, and then we're just going to call this level parent. And then we're going to get its transform to save it into that level parent. Okay, so now that we've got that, we'll be able to add our exit to our level parent as a child. So let's scroll down, and after we set the dungeon manager, we can say exit dot transform dot parent equals our level parent. Okay, so this will get everything into the level that we need, but we still need to clean up our level parent before we generate our next level. So let's go ahead, and at the top, we'll check if our level parent is not null, because for the first time, it will be null. We don't need to destroy it if there's not already one there. And then what we'll do is we'll say destroy, and then we'll say level parent, and then we got to say dot game object since this is a transform. Okay, so this is going to destroy the game object from the scene, which will take our level exit with us and make sure that nothing is remaining in our scene that belongs to our level before we generate our next level. Okay, so let's go ahead and hit save. But now if we were to hit play, we would no longer have this start function kicking off our first dungeon generation. So let's go ahead and do that. For now, we're going to keep our player reference, but eventually we're going to try to get our player out of this function because we don't necessarily need the player. Likely what we'll do is create a game manager that will kick off our next level for us at the beginning of the game. But for now, let's just say player.transform.position, and we'll say next level. Okay, and that will return the position that we'll move our player to, simultaneously generating our next level. Okay, so that gives us a good starting point here and all of the logic we need to actually get this working. So let's go ahead and go back to our level exit. I'm just going to close our camera follow script. Don't need that. Okay, and then inside of our level exit, what we'll do is say if the player has walked over us, then we can call that next level function. So to do that, we're going to set our other.transform.position, since this is our player, and we'll set that equal to dungeon manager.next level. So this is the mechanism that's going to spawn our player to the next level once we've generated it. Okay, so we'll save that, and then we can head back to Unity and give it a test. So we shouldn't need to update anything in our inspector, but we can go ahead and just double check. Everything looks good. Everything looks good. Okay, let's go ahead and click play. Our dungeon should generate and we should be spawned. And now we can go ahead and search for our level exit. I don't know why I'm sticking to hallways. Okay, so here is our level exit. So now when we walk into this, we're spawned at our next level. And we can see that this is clearly a different level. So let's go ahead and look for our exit. Oh, there's our exit. Okay, so now we'll enter our exit and we're spawned at a next level. And now we can actually do this infinitely because our dungeon will get cleaned up and then our next level spawned. And we can do this until we get bored of it. It'll just continue forever. Okay, so that is great work so far. So now that we've got this working, I want to just make one more adjustment. I want to add collision to our walls because you shouldn't be able to walk through the wall. So in order to do that, we're going to need to just change some settings on our player, and then we should be good to go. So let's stop playing. Another thing I wanted to update as well while we're making tiny updates is like I can see this blue after we are outside of our bounds of our dungeon. So let's go ahead and just change this blue color for our camera to this brown color. That way it will look like this is just the background instead of having that blue, and then we won't have like clear definitions of our dungeon. So let's go ahead and we'll click into our color for our background, and then we'll use the color dropper to select that brown color, and now we can see that our camera background is the same. Oh, it's because I'm playing. Okay. Let's stop. Oh, it's because it's my game scene. Okay, I'm like, I can't scroll out. Okay, so now we can see that the camera background is now the same as our dungeon. So we can't really see where the edge is there. And I think that looks nicer. So let's go with that. All right, let's save our changes. And now let's work on adding the collision. So let's first go to our wall tile map. And what we're going to do is we're just going to add a tile map collider, and that will generate all of the colliders for each of these walls. And it's only going to do it on our wall tiles, so our floor tiles will be still traversable. So we're going to click on add component, and then we'll say tile map, and we'll check tile map collider 2D. And we can see that each one of these now has a collider. So the floor tiles don't have any colliders over them, but we can see that these do. So that will work out for us. So now we can collide with our walls. But first, in order to get that working, we're going to need to change our rigid body for our player. Actually, let's go ahead and just test it out. So if we hit play, we'll see that we still don't collide with the walls. And that's because when we set up our player script, we made it kinematic. So we could move our player using like programming logic. But now we need to interact with our physics. So we're going to go ahead and change it from kinematic to dynamic. And that's going to give us a couple more settings. So what we want to do is change our gravity scale to 0, because if we don't, when we spawn into the world, we'll see that our player is traveling. They're falling out of the world because gravity is pulling them down. Granted, because we are using some programming to set our position, this is very slow because we're kind of like counteracting it with our programming. But let's go ahead and stop that. And we'll just set this gravity scale to 0 and save. And then now when we play, we'll see that we're not falling off the face of the earth, but we still are able to collide with the walls. However, you can see that we are tipping when we do that, and we're rotating on our x-axis. So we don't want to do that because like this will cause us to rotate when we like clip the edges of the wall. So let's go ahead and stop playing, and then we'll change our constraints, and we'll say freeze rotation on the Z. And that will do it so we can run into the walls without worrying about tipping over. So now I'm not going to tip over when I clip a wall. So let's like clip this wall, and you'll see that I just end up going around the wall instead of just tipping over. Okay, so that will give us collisions. Now we're actually trapped inside of our dungeon until we reach our level exit, and then we're trapped inside of a different dungeon. So that means we can't travel over our walls to get to rooms, and that's going to make our dungeon more difficult, more challenging, and more interesting. All right, so that is pretty much everything. So I just want to give you a pat on the back and say great work, because this is a very challenging and very complex thing that we did, and it took a long time to get everything working properly. I think this is the 10th video, so it took us a little bit. But I want to say good job and congratulations on getting this far. Our dungeon is really coming together, and with this change made, we have completed this section, so great work on making it this far. You can further customize your dungeon traversal by tweaking the start and exit room logic, and just making it your own. So in our next video, we're going to be adding our player sprite and animations for walking around. If you like this video, please like and subscribe, and don't forget to hit the notifications bell so you don't miss a thing. Thanks for watching, and I'll see you next time.